Well, hello. I hope you guys are all there. This is me recording my first lecture video for honors. Hope this works. So what we're going to do is start with honors chapter 2, part 1. So the first topic I want to discuss in chapter 2 is the concept of a coordinate system. The concept of a coordinate system. Okay? Why do we care about a coordinate system? Well, in this class, we're going to be making lots of measurements. And when we're not making measurements, we're going to be talking about measurements. So if we want to have measurements that we can agree upon, if we want to have measurements that we're going to compare with each other, we have to be in what's called a common coordinate system. Here's the idea. Let's say that I ask you guys to tell me or figure out how far away the door is. Imagine sitting in classroom and I ask you, how far away is the door? Okay? Well, let's say you are right here and I am right here and the door is right here. Okay? Well, you measure the distance to the door and you come up with that value. I measure the distance to the door and I come up with that value. Your value is much bigger than my value. So who's right? Well, in a way, we're both right. But if I'm trying to check my answers and I come and ask you, well, we're not going to agree. So this isn't a very good setup. We need to have a common coordinate system. If we decide to measure the distance, and I'm going to get rid of some of this mess here now. If we decide to measure the distance to the door, but instead of each of us picking our own personal coordinate system, let's just say we both describe a 0 point. A 0 point is a fancy way of saying the place we all agree to make our measurements from. So let's just say that is our 0 point, okay? Now we say let's make measurements to the door. How far away is the door from the 0 point? Well, we would both measure the distance as that value. And we'd be able to compare our answers to each other and we'd be able to come up with the same answers. So I hope that makes sense. We have to make a series of measurements, and if we're going to compare them, we have to be on the same coordinate system. Now, in our class, we're going to be working in one dimension, which means in our class, you can think of one-dimensional motion as one dimension as just being like a number line. We have our 0 point. We'll make all of our measures from there. We can measure this way, or we can measure the other way. And in one dimension, those are the only two options. We can go to the right, or the positive direction, or we can go to the left, the negative direction. But in either case, we're using a common coordinate system. We're using a common 0 point. We're measuring from the same place every time. Okay? Hope that makes sense. And I'm going to get rid of that. And that, and that. Nah, actually, I shouldn't have got rid of that. I'll get better at this. We'll call that the positive side, and that's the negative side. Okay. So, hope coordinate systems make sense. Moving on. The next thing I want to talk about is the concept of vectors and scalars. I want to talk about scalars, and I want to talk about vectors. Okay? Both vectors and scalars are mathematical devices, and they're mathematical devices designed to give us information. A scalar, whether you've called them these before or not, is something that you all are very familiar with. A scalar is simply a number. A scalar tells you the amount of something. How many apples are in my basket? There are 7 apples in my basket. 7 would be the scalar. 7 is not telling me anything other than the amount. A fancy word for the amount would be magnitude. A fancy word for amount would be magnitude. We are going to say magnitude a whole lot this year. So it's good to get used to it. A fancy word for amount is magnitude. Let's get that out of the way. I don't know why, but I kind of like erasing. So, scalars. What's an example of a scalar? Well, distance is a scalar. Distance is a scalar, and the units we will be using will be meters. We're going to be in metric this year. So distance is a scalar. It tells you how far away something is. So So you pick your 0 point and you measure the distance from the 0 point to whatever you're interested in. There's your scalar. Time is a scalar. Time we will measure in seconds. That'll be our official unit for time, seconds. Temperature. Temperature is a scalar. We'll measure that in centigrade or Kelvin. Okay? Speed is a scalar. How fast are you going? That will measure in meters per second. Okay? Those are scalars. Vectors. Well, what are some vector quantities? Well, vectors. Vectors are mathematical devices that tell us precisely two pieces of information. A vector is going to tell us two things. A vector is going to tell us the magnitude or the amount, but it is also going to tell us the direction. It's going to tell us what direction and the magnitude. So some examples of vectors. Position is a vector that we'll measure in meters, and I'll show you an example of that next. I'll draw you a picture in a second. Displacement is a vector. Displacement is a vector. We'll measure that in meters. Velocity is a vector. That is the equivalent of speed, except the vector version, and that is also measured in meters per second. So we have our vectors: position, displacement, velocity. Okay? These are all going to be things that tell us two pieces of information. So let's go down here and we'll draw you a picture and give you an example. So let's go back to our fancy number line. We have 0, 1, 2, 3. We have -1, -2, -3. So that's our negative direction, and this is our positive direction. So to the right is positive, to the left is negative. We're going to use positive and negative because it works for our mathematics. Okay? So let's just say my initial position, let's just say my position is right here. My position, horrible. My position is right there. And let's say that I move that way to right here. Okay? Let me actually go back. That was a bad way. I'm actually messing that explanation up. I'll come back to that. Let's go to I got ahead of myself. I apologize. Position. I'm right there. That's my position. My position is +2. I am 2 units away from the 0 point, and I'm 2 units in the positive direction. Let's say that's my position. That position would be -2. I am 2 units away from the 0 point, but this time I'm on the negative direction. Notice, my distance from the 0 point is 2 meters in both of those cases. In this case, I am 2 meters to the positive. In this case, I am 2 meters to the negative. The distance in both cases is 2 meters. Distance does not differentiate between those two. The scalar quantity position definitely differentiates. These two are not the same position. Over here is not the same as over here. They are totally different. One of them is positive, one of them is negative direction. With a vector, you can mathematically differentiate between being over here and over here. So that is one of the great values of the quantity of a vector, okay? I can't seem to turn off my laser now. Oh, now I know how. There we go. Haha, I got stuck on my laser. Okay, the next one I want to talk about is displacement. I want to talk about this one right now, okay? So displacement. Going back to our number line, erase this and this. Erase these two things, erase this. There's my number line. Displacement. And I'll write down here below it. We're going to use, for displacement, the symbol triangle X. Okay? Triangle is the Greek letter delta. The Greek letter delta is going to be mathematically meaning change. X is going to be our variable for position. So my position is the variable x. Delta x is going to be the symbol for displacement. And displacement just means a change, delta, in position, x. So Delta x gives us displacement. I am going to, for our purposes, put that little arrow on top of the x. That symbolizes that delta x, displacement, is a vector quantity. So when I write this down, if I put the little arrow there, you know I'm referring to a vector. And you know then that the number, that any value associated with this has to have a positive or a negative sign. So let's do an example. First of all, change in position, like change in anything else, displacement, is going to be the difference between a final position and an initial position. So delta x is going to be the difference between your final position and your initial position. So what does that look like? Well, let's say my initial position is right here at the 0. And let's say my final position is right here at the 2. Okay? So I'm going from an initial position of 2. My final position is, my initial position is 0. My final position is 2. So 2 minus 0 would give me positive 2 units. My displacement is 2 units to the right. I started here and I went to the right 2 units. Positive 2. All right, let's do another example. Let's say this time I start right here with an initial position of 2, and let's say I finish with a final position of negative 2. Okay? So my initial position is 2, my final position is negative 2, so negative 2 minus 2 gives me negative 4. And let's have a look. Negative 4 means I started here and I moved 4 units to the left, to the negative side. 1, 2, 3, 4 units to the negative side. That gives me my final position. I hope that makes sense. And as far as I can tell, that should wrap up the first video series. So I'm going to go ahead